This will be our first video in solving trig equations. So how do you solve trig equations? First, you have to solve by either isolating the trig function. Sometimes you need to get it equal to 0 and you'll have to factor. And sometimes you are going to have to use an identity to replace something and then factor. This video, we're going to focus on the isolation step. All right, once you have it solved though, I know I'm using solve to say we're going to solve, it's a little confusing, but once you have this first step done, then you have to take it one step further and find two angles, two number answers with pi in them for each of your thetas. There's two angles and we're going to use the unit circle. Notice there's a little asterisk there because there's a small caveat. If sine, cosine, secant, or cosecant is 1 or -1, then you only have one angle. Tangent equaling 1 or cotangent equaling 1 still gives you 2. And then also if sine or cosine is not between -1 and 1, if it's equal to 2, 3, a million, then that means there are 0 answers. We don't have any fractions on our unit circle that are bigger than 1 or more negative than -1. All right, let's do some examples. Solve 2 sine theta plus square root 2 equals 0 on the interval 0 to 2 pi. Okay, so this is what I mean by solve to isolate the trig function. We have 1 sine theta in here, so we want to get this piece by itself, which means that I have to get rid of this 2 and this square root 2. So subtract your square root 2 over to the other side, and then we're going to divide by 2. All right, so my first step is done. I have solved for sine theta, cosine theta, whatever your trig piece is. Now you have to do that second step, which is use your unit circle and figure out what are my actual theta values? What are my angles where this occurs? So sine theta equals negative square root 2 over 2. And we're going to use the whole entire unit circle because this says from 0 to 2 pi. All right. Remember, your coordinate points are written cosine sine, so I'm looking for where the y coordinate piece is negative square root 2 over 2, and that's down here and down here. There should be 2 angles, and your answer should be in radians because the original problem says 0 to 2 pi, and 2 pi is radians. So 5 pi over 4 and 7 pi over 4. And we're done. That's it. So you're going to isolate your trig piece and then use your unit circle to find the 2 angles. All right, let's do another one that's somewhat straightforward because it's a cosine piece. So we need to isolate our cosine alpha, which means I want to add this 4 square root 3 over to the other side. And divide by 8. You can simplify 4 over 8. Neither one of those is under a square root, so 4/8 is 1/2. You can put the 1 there if you want, but it might be clearer to not have the 1 there. And now I've done my first step, so now use your unit circle to figure out what are my actual angles. Where is cosine equal to positive square root 3 over 2? Cosine is the x piece, so where's my x piece? Oh, there's one. Equal to positive square root 3 over 2. And that occurs at pi over 6 and 11 pi over 6. Your answer should be in radians for all of these. You'll notice that they all say 0 to 2 pi, so that means we're in radians. All right, let's do a tangent problem. So same exact idea. We want to solve for tangent, so get tangent by itself. So I'm going to subtract my 2 over to the other side. And then divide by 2, so that way tangent is by itself. Now, do your second step. Take it one step further and look at your unit circle. Where is tangent equal to 1? You may have to add all of these tangent values onto your unit circle. Remember, that is the sine numerator divided by the cosine numerator to get all these numbers in green, which are my tangent values. And it's kind of hard to see because there's a glare, but tangent is +1 down here by my thumb and up here by this thumb at pi/4 and at 5 pi/4. All right, so those first three were somewhat straightforward because they were sine and cosine and tangent pieces. We're used to using the unit circle to figure out sine, cosine, and tangent. But let's do two examples where we have secants and cosecants. So we could do the same thing with cotangent. It's the same idea. I want to isolate my secant, so I'm going to subtract 2 to the other side. And then you use your unit circle to figure out what that angle is, but I don't know my secant values very well, so I'm going to actually flip this fraction. So all I have to do is flip this fraction to get my cosine fraction. If secant is -2, cosine is -1/2. So the reciprocal of secant is cosine, and then flip your fraction. So that means if secant is -2, cosine is -1/2. And now I can use my unit circle straightforward to figure out where is cosine equal to -1/2. Where is the x coordinate equal to -1/2? That is at 2 pi/3 and 4 pi/3. All right, if that threw you for a loop, we're going to do one more example just so you have two examples of this. We're going to solve for cosecant. So I need to add 2 over to the other side. And then divide by √3. All right, so now let's figure out where on my unit circle is cosecant equal to 2 over √3. I don't know my cosecant values. So what's the reciprocal of cosecant? The reciprocal of cosecant is sine. Reciprocal means flip that fraction. So cosecant is equal to 2 over √3, where sine is equal to √3 over 2. I do know my sine values on my unit circle. So where is sine equal to √3 over 2? Where's the y coordinate equal to √3 over 2? That is at pi/3 and 2 pi/3. So for all of these, maybe you know your secant and cosecant and cotangent values for the unit circle, and if you do, that's great, but I don't have those memorized. So instead, once I've gotten my secant and cosecant values isolated, I just flip the fraction and use the reciprocal piece because I know my cosines and my sines. Okay, let's do 2 more examples that are similar idea, similar steps, but slightly different. Because now we have a squared here. You could solve this by factoring. This is a difference of squares because I have a minus sign here, and I can square root 4 and I can square root cosecant squared because it's squared. Or you could just isolate this cosecant piece, which means that I would need to add my 4 over to the other side and then square root it. When you square root, there wasn't a square root in this original problem, so I added the square root of 4. The square root of 4 is 2, and because I added that symbol in there while trying to solve it, that means I need a plus or a minus. So actually, I am trying to figure out where is cosecant equal to +2 and where is cosecant equal to -2. Again, just like the last 2 examples, I don't know my cosecant values, so I am going to use reciprocals. Cosecant is equal to +2, where sine is equal to +1/2, and cosecant is equal to -2, where sine is equal to -1/2. And so where does that occur? We're going to actually use 2 angles from this one and 2 angles for this one. You want to include all 4 angles in your final answer. So sine is +1/2 here at pi/6 and 5 pi/6, and sine is -1/2 here at 7 pi/6 and 11 pi/6. So all 4 of those answers are included in your final answer. So those 2 specifically came from here, and those 2 specifically came from here, but it doesn't really matter. Just include all 4 angles. Let's do one more of these. Let's get our cotangent isolated. We could use the difference of squares, even though 3 is not a square rootable number. We'll just leave the square root symbol in our answer. But I'm going to just solve it the way I did before. So I am going to add 3 over to the other side to isolate my cotan. And now square root it. Because there wasn't a square root symbol in the original problem, that means that I need to have a plus or minus. All right, I don't know my cotangent fractions. They're not hard to figure out, but instead I am going to use my tangent fractions. So I'm going to flip this. And I have my positive version and my negative version. I am going to rationalize the denominator. So I'm going to bring my square root 3 to the top and drop my symbol in the bottom. Same idea, bring your square root 3 to the top and drop the symbol in the bottom. This is my shortcut. So where is tangent equal to square root 3 over 3? And where is tangent equal to negative square root 3 over 3? That would be my positive square root 3 over 3s are here at my thumbs. That's pi over 6 and 7 pi over 6. And my negative square root 3 over 3s are here at my thumbs at 5 pi over 6 and 11 pi over 6. Include all 4 angles in your final answer. And we're done. So for all of these, I isolated my trig piece, and then I used my unit circle to find my 2 angles.